We did the stream this morning and it worked, but the audio was out. So I want to make sure now, real quick, before we get started, that the audio will be functional throughout this so that we can kind of kick it off there. And I had to delete the last video because you couldn't hear anything. There we go. Okay, cool. Looks like it works. So yeah, in that case, I think we are all good to go on the tech side. I mentioned we will give it a few minutes here, and then I will pull Dennis up in just a moment. But yeah, the one that we did this morning was kind of a walkthrough on how we handled inscriptions through smart accounts within the People's Alliance with our smart wallet service. So that was definitely pretty interesting. And then what we're going to be doing today, like I mentioned, is ZetaChain, talking about this idea of Omnichain. Then we'll have Tycho on later on to talk about what it's like to build on a base rollup. Of course, with high level of Ethereum equivalency. And then we'll be having Biconomy on to talk about modular smart accounts, and then Alchemy on to talk about ERC 437 and kind of the work that they've been doing in that vertical as well. But this is our first kind of external session. Like I mentioned, the first one that we did this morning was all about Particle, but we're kind of kicking it off now with ZetaChain, and then we have 3 more over the next 48 hours or so as we kind of run through the workshop marathon this week. So we have 2 places that we're currently streaming this. The first is here on Discord, where of course we have the audience in the workshop, and then we also have a live stream going on YouTube. So this will be recorded after the fact as well. So if anybody can't make it through the whole thing for time constraints, then feel free to head over to that link right there. That'll be recorded, and it's also, of course, currently live on there as well. But we'll probably give it another 5 minutes or so, and then we will kick it off. Like I mentioned at the session this morning, is that basically everybody that attends these, if you are a verified developer, so if you have the verified developer role here on Discord, meaning that you connected your GitHub with Particle, then what we'll do is give everybody that attends each workshop or every workshop about 10,000 ally for attending. That's if you have the verified developer role and you attend this one and the next 3 that we're hosting. So it's just kind of like a cool thing that we're doing for the developers, that they verified that they have a GitHub account that's active on our server. So if anybody here has that role, which I see a few that were in the session this morning, then I have noted down your name, and I'll kind of continue to note it down as we go through the next workshops here. But it looks like we have about 12 people now. Like I mentioned, the live stream on YouTube seems to be working now, so I think we are good to go on that side. It doesn't seem like there's any questions in the chat, so I think we should be able to kick it off here in just another few minutes. To kind of set some expectations, this will be probably around 30 minutes or so, maybe 40 minutes. And we're going to kind of learn all about ZetaChain. ZetaChain has been almost the talk of the town over the last 2 or 3 months. And of course, at Particle, our smart wallet service is directly compatible with ZetaChain. So we've been really excited to kind of support their growth and do what we can to kind of help consumer-facing applications, and this idea of a next-generation Web3 application be made using ZetaChain as a foundation. And of course, also in many cases using Particle as that mechanism for social logins and kind of consumer onboarding. So we're really excited about the direction that ZetaChain is going in, and of course, kind of the workshop that we're going through today. So I think without further ado, what we can do is maybe, Dennis, if you want to go ahead and raise your hand, I can get you up here and make sure that your microphone is working and that we are good to go on that. So let's see if I can go ahead and bring you up here. There we go. Invite to speak. Let's see if that'll do it. Perfect. Hello, can you hear me?
Hello, can you hear me?
Yep. Yeah, sounds good. I think you are coming through pretty clear. Is your all the audio sounds good on your front?
Yeah, thanks for having me.
No problem. Well, then maybe what we can do now that you're up here is kind of as we roll into it here, maybe the best way to start would be to get an intro from you. If you want to kind of tell us about, what got you into ZetaChain, what got you into Web3, kind of your experience in this space thus far. It'd be dope to kind of learn a little bit more about kind of what brought you to this point in Web3, and then maybe we can learn more about ZetaChain after that.
Absolutely. By the way, I can't share my screen, so if that's yeah, I just wanted
Gotcha.
to
Let me see if I can fix that.
Sure. I don't need to share my screen right now, but yeah, anyway, I can start. My name is Dennis. I lead developer experience at ZetaChain. I've been in crypto since 2019. I started contributing to the Cosmos ecosystem, and I've been building tooling pretty much ever since. I built tools for building blockchains, and yeah, joined ZetaChain in April this year. And the reason why I joined is I think ZetaChain has a very interesting value proposition and just utility in general, which is acting as a hub for Omnichain contracts. And coming from the Cosmos ecosystem, I'm very familiar with how important the idea of multi-chain is, right? There's not going to be one single blockchain. We're going to have hundreds or thousands of blockchains, and this creates interesting challenges on how to solve this. Now you should be able to see me actually. So, hey everyone. So yeah, it's very difficult to have these hundreds, thousands of blockchains all talking to each other, and you can connect all the chains together, one-on-one connection, or you can have hubs, right? In the Cosmos ecosystem, hubs are starting to emerge, which are blockchains that primarily route transactions between other blockchains. So ZetaChain is kind of like that, but for also for blockchains that are not part of the Cosmos ecosystem. In fact, it's a platform where you can build that can talk to any blockchain. So yeah, it's a very exciting idea, and it's a novel way to build future-proof dApps that needs to be kind of hyper connected to allow any user of any blockchain to be able to interact with it, to put inputs and produce outputs between blockchains.
Definitely makes sense. I remember when I first joined Particle in September, I went to Singapore, and one of the first people I ran into was, I think it was your community manager. And when I first learned about ZetaChain, I loved the concept and the idea of promoting like true cross-chain interoperability. I mean, it really is like when you think of kind of the core like fundamental issues in Web3, it almost always comes back around to the idea of multi-chain interoperability. So I think the fact that you guys are addressing this head on and of course doing it successfully is really impressive, and I'm always interested to hear about it, because I think it was maybe the third or fourth workshop, or not workshop, a talk I did. It was in Singapore, and I think you were there on the panel as well, where I got to learn a little bit more from that side too. So it's been really interesting kind of watch you guys grow and of course get to the position that you're at now, which I think you guys have definitely been pretty successful in capturing the attention of a lot of developers and users, and because of course for good reason. I mean, you guys are solving a pretty big issue. So I'm excited to kind of dive into the topic today. Maybe before we kind of like jump right into it, do you want to give a quick overview of kind of what you had in mind to cover on the ZetaChain side in terms of maybe showcasing what it's like to build ZetaChain, and kind of give that initial introduction for developers?
Yeah, so on this workshop, we're gonna be, well, hopefully we have enough time, but we're gonna attempt to build a cross-chain swap contract, cross-chain omni-chain contract, and deploy it on ZetaChain. Maybe use it. If we don't have enough time, at least I'll give you some general direction how this can be implemented. But yeah, again, ZetaChain is a platform for omni-chain contracts. It also supports cross-chain messaging. It's a bit less exciting, but it's also there. It's a useful tool to have, but the focus of this workshop is going to be primarily on Omnichain, because we believe that this is going to be the architecture that will let dApps scale to hundreds and thousands of blockchains.
Perfect. Well then, yeah, I think that's a perfect topic. A big part of kind of the goal with these different workshops that we're running is to give developers an idea of the stack that's required to build this idea of a next generation application. So something that truly addresses and takes advantage of a lot of these brand new solutions in Web3. So I think this is the perfect way to kick that off with the idea of Omnichain. So maybe I'll kind of leave it to you to take it away and take as long as you need. Like I mentioned, I think we have 30 to 45 minutes. So as soon as you're ready, then we will kind of pop back in and maybe do some recap and take some questions.
Awesome.
Let me know if you can share your
Share.
screen. Yeah, I think you should have permissions now. I don't know if it works. Should be the button right next to the.
Yeah, I'm gonna have to quit and re-log in, but it should take about a couple of seconds. So
Sure, no problem. I will pull you back up when you're in. All right, perfect, guys. So while he's coming back in, for you guys that are in here, if you have the verified developer role, stick through this because at the end I will kind of go through every name, make sure that we can tally up each verified developer that is here in the space. So make sure that you guys stick around, and then I will do that tallying at the end. Perfect. I think looks like you are back on stage. Is it working now? There we go.
yeah,
Sounds
you
good.
should be able to see my screen. Okay, cool. So let's begin. ZetaChain is a platform for Omnichain contracts, and we're gonna build one today. Gonna give a brief overview of what that entails. Hopefully you see this diagram. It looks a bit complex, but I'm going to go through it pretty quickly. So it's a Cosmos-based EVM chain where you can deploy Solidity contracts, right? And the only difference with these contracts is that you can call them from any connected chain. Currently, that's Ethereum, Polygon, BSC, and notably Bitcoin. And you can deposit tokens into this contract, into the contract that you're building, and you can withdraw tokens to supported blockchains. So that's everything pretty much, right? It's regular Solidity contract that can be called from connected chains, but this creates a lot of interesting opportunities, specifically when you, for example, want to move assets or you want to create a dApp that can accept input from any blockchain. So in this example that I'm going to show today, we're going to be swapping tokens from one chain to another. ZetaChain is not a platform to just for building swap contracts, right? It's a general purpose platform, but swap is just a great example because it's very short, to the point, and everyone's familiar with what swapping is. So it's just a good example on how this is done. So this diagram kind of represents the whole flow, right? You have an account on, let's say, Ethereum, and you have a contract on ZetaChain, this Omnichain contract that will implement the swapping logic. So what your users can do is they can send native gas token, ETH, or supported ERC20 tokens to something known as TSS address. Each chain has ZetaChain specific TSS address. You send tokens to this TSS address, and they get deposited into your contract. Simple as that, as a wrapped asset. So if you send one ETH to the TSS address on Ethereum, it gets deposited into your Omnichain contract as a wrapped ETH that we call ERC20. And it's pretty much the same as ERC20, except you can call withdraw and move these assets back to the chain from which they were deposited. So that's pretty cool. You can deposit tokens from any connected chain. What you can also do is you can supply data, right? For example, if you're doing the swapping, you need to know which token you want to get in the end, right? So you can supply arbitrary data in the input data field of your transaction. The first 20 bytes is always Omnichain contract address, just so that ZetaChain knows which contract to call, and the rest is just a message. So you can pass any data you want. In our example, it's going to be simply a token you want to get and the recipient that you want to transfer the token to. So yeah, I hope that's pretty straightforward. Let's start building. So you can find everything about ZetaChain when it comes to code on GitHub, github.com/zeta-chain. You can read more about it here. But let's just start and gonna increase the font size a bit. So what we're going to do is we're going to clone the ZetaChain's template. It's a great way to start building. Just clone the template, open it up. It's a very simple template, doesn't really have much here. I already have it somewhere here. Okay, just attach the changes. So it should be a clean. Okay, now it's a completely brand new template. It has nothing, just a package.json that imports all the packages. Run yarn to install dependencies. If you're following along and you don't have Zeta tokens, just open the documentation. I'm not going to go through that process, but there is a link to a faucet and you can get all set up, but it pretty much involves some commands like npx hardhat accounts. You can save an account. I already have it. That's why I'm not going to go through this process. But once you have set up, you will get a new .env file, which has your private key. And now we can start building. So npx hardhat has a bunch of useful commands for ZetaChain that we built, specifically that generate code, so you don't have to create it from scratch. So we have a command for messaging, we have a command for Omnichain contracts, and we're gonna use the Omnichain command. And it's pretty simple. It just accepts a contract name and an optional list of arguments. So the arguments are the data, bits of data that will be passed in this message. So in our case, that's going to be a target token, which is going to be of type address. You can pass types after a colon, and a recipient. So the recipient is just an address, but we're not going to specify type address, and I'll explain why in a minute. So this command will generate a new contract file that imports all the necessary bits and pieces, and it also generated some hardhat tests for us to make the process easier. So whenever an Omnichain contract gets called, a special function gets called onCrossChain call. It has a specific signature, but other than that, it's not really special, right? It's just a function that gets called whenever someone deposits tokens into your contract and passes a message to it. So this is going to be the place where we'll make the changes to actually do the logic, right? Implement the logic of our swap contract. So by default, it just decodes the data, though we can even comment it out. We don't provide any tooling for you to do the swapping necessarily, right? You can choose whichever DEX you want, whichever liquidity pools you want. We have internal liquidity pools on ZetaChain to facilitate cross-chain transactions, so you can use that, but you can also use other pools. Okay, so let's implement the logic. We have two bits of data coming in this message. One is token address, so let's create a variable for it. So it's going to be target token address, and we have a recipient address. So it's going to be in bytes. The reason why it's not an address is because ZetaChain supports Bitcoin, and Bitcoin uses Bech32 addresses, which don't fit into Solidity's address type. So this is also an option. We don't want to limit you to just EVM chains, so we're going to store address in bytes. Now we need to decode let's imagine our contract gets called, the onCrosschain function is executed, and we need to decode the message just so that we can get the token address and the recipient address. Now it's a bit different because we can have a transaction coming from Bitcoin, or we can have a transaction coming from an EVM chain. So the way we can dispatch different logic based on the chain that the transaction is coming from is using this context parameter, right? So if we type context chain ID, we'll get the chain ID of the chain basically. And let's say if it's Bitcoin, for Bitcoin we're using chain ID 18332. Don't ask me why, it's just a convention for Bitcoin testnet, I mean. So let's create a variable for that. So it's going to be a constant Bitcoin and 18332. I think it's actually a port number, default port number of Bitcoin node or something, but it doesn't matter. It's just an integer that we use to identify Bitcoin. So let's say if this transaction is coming from Bitcoin, we need to parse the message. When coming from Bitcoin, the input data is stored in the memo, and we don't have ABI encode and decode for Bitcoin, so it's up to us to really fit these bits of data properly in the memo and decode them correctly. So we need to come up with a convention. It's going to be very simple. The first 20 bytes is going to be a token address, and the next 20 bytes is the recipient address. So let's say target token address is the first 20 bytes, and we need to decode them. We have a library that will help you do that. So it's called bytes helper lib, and it has a method called bytes to address. And I'm gonna show where this is coming from. So if you go to ZetaChain's GitHub and go to the toolkit, which is a library that pretty much contains all the functionality we're using right now, it has a contracts directory with byte helper lib, and it's just a helper utility that has functions like bytes to address, so we don't have to store them in our source code. So let's import that library so this error goes away. So we import ZetaChain toolkit. So you can install it from npm, but in the template it's already included. So import bytes helper lib, and we have access to this useful method. So now we need to decode the next part of this message, which is the recipient address, and it's pretty much exactly the same. So recipient address, bytes helper lib, and then bytes to address. Okay, so recipient address is actually bytes, so we need to convert this address into bytes, so we can use ABI encode this address into bytes. Okay, now we should have both token address and the recipient address in our variables, and we hopefully handled the case when the transaction is coming from Bitcoin. The next step is the next case is if it's coming from an EVM chain instead. So we can actually take the logic we commented out and move it here, because it looks pretty good, except we store the recipient in bytes and not in address, because from EVM you might want to swap to another EVM chain, but you also might want to swap to Bitcoin, in which case it's going to be bytes. So this is pretty good. The only thing we need to do is to put these values into our variables. Okay, so this should be good. We handled the Bitcoin case. We handled the case when a transaction is coming from an EVM chain. Now we actually need to do something with these with this data. So what we're gonna do next is we're gonna swap. But before we swap, there's also two scenarios possible, right? One is when you swap native tokens. So when a native token is coming in and a native token is being withdrawn, that's one scenario. The other scenario is when a native token is coming in, but an ERC20 is coming out. So the way ZetaChain works is that when you withdraw a token from ZetaChain to a destination blockchain, validators of ZetaChain sign a transaction basically on your behalf on the destination chain to transfer the tokens being withdrawn from this TSS address that validators have custody over, collective custody over, to the destination address. But when they do so, they incur gas fees, and you need to offset these gas fees. And the way you do this is you allow the contract to spend tokens of the destination chain on ZetaChain. So basically, if you're withdrawing tokens to Polygon, you need to have Matic on ZetaChain to cover these gas fees. So when these tokens are withdrawn, so let's say you're moving USDC from Ethereum to Polygon, you're depositing USDC from Ethereum, then you're swapping one version of USDC for another version of USDC that you intend to withdraw to Polygon. You need to cover the gas fees, and they're in Matic. So you need to swap this incoming USDC, a fraction of it, for Matic, and ZetaChain will burn these tokens and withdraw the rest. Hopefully that makes sense. So you have basically you have USDC barely coming to ZetaChain, and then it gets split into Matic for fees, and then it gets also USDC Polygon being withdrawn. So if you're inputting one USDC, it's gonna get swapped for like 0.001 Matic, which goes for fees, and you're gonna get like 98 USDC. I'm making these numbers up, but you get the point, right? You're gonna withdraw a smaller amount. Anyway, now that's out of the way, we can actually implement the logic for this. So we have our target token address here, and we have a helper functions to actually tell you how much you need to have in order to withdraw these tokens. So target token address, these tokens that are deposited to ZetaChain are called ZRC20s, right? And we have a interface called iZRC20. You pass the token address to it, and it has a method called withdraw gas fee. You can learn more about it in the protocol contracts repo. So if you go to GitHub, ZetaChain/protocol contracts, there are a bunch of contracts, and the one that we need to know about is here. So you can read more about the implementation of it, but basically withdraw gas fee returns two values. One is the address of the token, and the other one is the actual amount of the fee. Okay, so now we know how much we need to have and which token we need to have. we need to swap, because right now we don't have any tokens. We only have the ones that were deposited. Let's say it's USDC from Ethereum. So now we need to swap a fraction of it for Matic to cover gas fees, and the other part we need to swap for USDC from Polygon to be able to withdraw it. So we're going to be using internal liquidity pools that exist on ZetaChain, and we are going to use the helper utilities again. If you go to the toolkit, there is a byte helper lib, but there's also a swap helper lib that has a swap tokens. Swap tokens for exact tokens. We're going to use this function. So bytes helper, swap helper lib. I'm going to use this function. You can read all the parameters that it accepts, but basically it needs a system contract, which is just a contract that handles all these cross-chain transactions on ZetaChain that actually is calling your Omnichain contract. So it needs wrapped Zeta address because it's swapping through wrapped Zeta if there is no direct pool for the tokens that you want to swap. It needs Uniswap v2 factory address because it's using that, and it needs a router. Let's see what else needs. Okay, ZRC20, which is going to be the token that that you want to swap to, the gas fee, and gas ZRC20, and the amount. Okay, so let me explain a bit. So this ZRC20 is actually the token that you already have, and this is coming from the parameters of this function. So these are the tokens that get deposited. If you're depositing ETH, then this will be an address of a wrapped version of ETH on ZetaChain called ZRC20 ETH, and this is exactly the address that you're going to get. The gas fee is what you want to return, what you want to swap for, and the amount is the input amount. So this will return the input amount for gas, right? The amount that you actually put in to this function, and you will get the exact amount that you need for swapping. So this is swap for the fee token. Now what we need to do is we need to swap for the actual token that you want to get and withdraw. So we also have a helper called doSwap, and doSwap is pretty much exactly the same. You can just copy all this stuff, and it needs to know which token it gets, and it needs to also know the tokens that you're putting in, which is the amount. Amount is coming from here minus the tokens that you spent for gas, so input for gas, right? So this is the amount that you deposited. If you deposited 1 ETH, then it's going to be 1 ETH minus the gas that minus the ETH that you spent to cover gas costs on the destination chain, and the target token address. So yeah, that's it, and it also returns the output amount. And this is useful to know because you need to specify how much tokens you will be you'll be withdrawing. Output amount. Okay. Make sure it's all formatted. Okay, now we need to import swap helper lib, which is okay. Now it doesn't throw any errors, which is a good sign. So, okay, at this point, what you should have is you should have tokens for covering the gas fee, right? Using this swap, and you also should have tokens that you swapped um, the destination tokens, basically. Now what you need is you need to withdraw tokens. But before you can do this, you actually need to approve the target token address to spend gas fees. So you have gas ZRC20, which we got from here, right? And we're also using a ZRC20 interface, and we're approving the target token address, which if you're swapping to USDC Polygon, this is going to be it, and you're got the C, and you're allowing this target token contract to spend this gas fee on your behalf. And finally, all that's left is you need to actually withdraw. So the only reason why we call it ZRC20 and not just ERC20 is because this token has a special method called withdraw that lets you withdraw it to the chain from which it was originally deposited, right? So you specify recipient address and the output amount going to be the amount that you received through this swap process. You don't need to specify the chain because each ZRC20 has a single chain which corresponds to it. So it will be withdrawn to the chain from which it originates. Okay, so this looks good. Hopefully no mistakes, but yeah. What else we need to do? So we have these two useful hard hat tasks. One is to deploy this contract to ZetaChain. We're not going to be doing anything with it. It's a very simple task to just deploy a contract. But we also have an indirect task, which is a bit more complex, but all it does is it lets you send tokens to either a TSS address if you're sending native tokens, or to a ERC20 custody contract if you're sending ERC20s. So it's for interacting with your Omnichain contract, and it's all automatically generated based on the fields that you provided. The only change that we're going to make to it is we're going to make it compatible with Bitcoin. So we have recipient as a parameter, but we need to make some adjustments to it because it can come in two forms, right? It can come in a hex form if your recipient is on EVM chain, then you pretty much don't need to do anything. But it can also be in batch32, so you need to convert this batch32 into hex form so you can ship it safely to ZetaChain. So we're going to use this library called batch32 and try to decode the recipient address. If it succeeds, we don't even actually care what it decodes to, but if it succeeds, then it's a valid batch32 Bitcoin address, and we can use utils from ethers to actually pack it into bytes. So what this does is we basically convert a string into recipient batch32. We convert a string into hex so it can be included into the input data from in your transaction. So let's import batch32 from batch32. And if there is an error, this means this is an EVM address, so we don't need to do anything. And the only thing that's left is to change the address to bytes again, because it might be Bitcoin. So yeah, that should be it. Now, what's left to do is to try it out. Let's just we have a contract, we have a task to interact with it. Let's use hardhat to compile the contract, compiled successfully. Now we can use the deploy task that that the template has generated to deploy to Zeta testnet. So again, you will need tokens for this. I already have a .env with my private key here. If you don't follow the docs, it should be pretty straightforward. Just run npx hardhat account save and npx hardhat faucet. You will also need some tokens from on a connected chain to be able to send it. So, okay, we've deployed a contract. Now let's use the interact task to interact with this contract. Okay, I'm forgetting which arguments we need. So we need an amount. Let's say let's send a simple transaction from Gurley to Mumbai. I'm going to send a small amount, 0.01 ETH. If it's a native token, we don't need to specify anything. It's going to just default to the native token. You can also send the ERC20s. So the contract is going to be the one that we've deployed it to. Recipient. For recipient, I'm just going to use my address. I don't remember it. So I'm going to use the balances command to verify the balances just to make sure that I also have tokens. Okay, this is my address. I can just copy it, paste it here. And the target token is the token we want to get. And this is something I will need to copy from the docs because I don't remember. This is a ZRC20 address of the token I want to get in the end. So we have a list of tokens here. So ZRC20 tokens, you can get ZRC20 address, ZRC unconnected chain. I'm going to be swapping for Matic. So I'm copying this address. So again, it's not the address on the destination chain, it's a ZRC20 address on ZetaChain. And that's pretty much it. The only thing that's left is the default network lag value is early testnet. Okay, it broadcasted the transaction, and that's good. Now we can, this is a hash on Gurley. What we can do is we can use the other command we have, which is cctx for tracking transactions to actually start tracking this transaction. In the meantime, we can take a look at this contract. Let's use block. Okay, no, I don't want to open MetaMask. Let's open Block Scout and find our contract here. You can use ZetaScan, but Block Scout is good for just kind of browsing and interacting with contracts. I've deployed the contract before, so it automatically verified it, which is good. But of course, you can verify it manually. And we can also look up this transaction. So this transaction we actually can't find on ZetaChain because we didn't broadcast it to ZetaChain. We broadcasted it to Gurley. So let's search it here. And indeed, it has been broadcasted. It's a simple token transfer transaction from my address to a TSS address. So to interact with any contract on ZetaChain, you need to send tokens to this TSS address, which is owned by validators of ZetaChain, and it includes the input data. So the first 20 bytes should match our contract address, which it does, and then we're just passing the data of the destination token we want to get, as well as my own address, because I'm sending it to myself on Polygon. So this might take a while. It kind of depends on how many transactions we have in the network currently. If we have time, we can wait a bit longer to just see the result of this transaction. And we already got a transaction on ZetaChain, which is great. So you can see that our inbound transaction generated 2 transactions, one from Gurley to ZetaChain and one from ZetaChain to Polygon. Please ignore undefined. I just need to update the toolkit. Doesn't matter. Anyway, the good thing is that we saw this transaction here, and we can find it on Block Scout on ZetaChain to confirm. No, it's actually cross-chain transaction. We can't find it here. Let's use ZetaScan instead. So ZetaScan is the official explorer, and it's a more graphical, nicer way to browse this. So you can see that we've deposited 1 ETH from Gurley to ZetaChain, and we have one related cross-chain transaction which ends in 7D, which is 7D here. So we can click that, and we will see that we will be getting 0.25 Matic. It hasn't been processed yet. It might take some time for it to be finalized, but I hope you get the gist, right? In just 40 minutes, we pretty much from scratch created a cross-chain contract that is capable of swapping native tokens, ERC20 tokens between Ethereum, BSC, Polygon, and Bitcoin. Very capable in just 70 lines of code. We modified the interact task to make sure that we handle Bitcoin transactions nicely, and we've actually tried interacting with it and succeeded. So yeah, in just 40 minutes, you can implement an Omnichain dApp that can swap tokens. You can come up with cool, interesting ideas on how to leverage this. So again, this contract can accept input from Bitcoin, so you can implement blending any DeFi applications. You can mint NFTs on ZetaChain based on the tokens that users deposited on Bitcoin, all sorts of things. And while I was talking, we actually got a confirmation on this transaction. So we actually swapped to Mumbai. Let's just make sure that so it might take a while for the indexer to catch up, but let's see if we have an inbound transaction. And we do in fact have inbound transaction of 0.25 Matic just a minute ago. So yeah, I think this covers pretty much everything. Hope that was useful. If you're interested in building on ZetaChain, you can visit zetachain.com/docs. Swap is just one of the tutorials we have. We also have a staking tutorial. We have tutorials on partner projects like GoldSky and of course Particle Network. The Particle team has created an awesome tutorial, so you can follow the link and learn how to integrate Particle Network with ZetaChain, which is absolutely awesome. And we have a new tutorial coming soon dedicated to NFTs and building a front-end application for this NFT dApp. That's it. I think we can open for questions now.
Perfect. That was awesome. I was watching that the entire time, and it's actually a lot simpler than I thought it was. I've looked into this idea of leveraging ZetaChain, and I like this sort of visualization of almost as like a piece of middleware, like you showed with the Explorer, like taking a transaction or like an asset from one chain and then using that as sort of like an intermediary to bring to the other chain. In the mechanism that you used, made it look really simple. So I'm thinking now maybe I need to spin up a demo or an application that leverages this with Particle, because it is really cool. And I like the highlight on Bitcoin too, because really I actually saw somebody asked in the chat, but we've like Bitcoin has been a pretty big topic recently, and we actually just released BTC Connect today. So I think it was definitely timely to make sure that was included, because this idea of cross-chain interoperability, especially with Bitcoin, has been a pretty big deal too. That's what we've been focusing on recently as well, and I think it complements what you guys are building on ZetaChain quite well. So I think overall, really cool, perfect workshop. I think that was a great introduction to not only like what ZetaChain is conceptually, but how developers can get started working with it. But I guess like my main question would be for those that are here live in the audience, that are watching the live stream and that are watching back at the recording. For a developer that wants to get started on ZetaChain, that wants to get started building with your tech stack, I know that you mentioned the documentation, but what's maybe a kind of like the best initial point for them to go to if they want to start, building their application on ZetaChain? Would it be the docs, or what would you recommend a developer do if they want to get started today?
Yeah, so we're putting a lot of emphasis on tutorials and kind of the gradual increase of complexity of tutorials. So the first tutorial is just you're creating a contract, calling it, that's it. Then we have a swap tutorial and a staking tutorial, and we have some videos as well. So yeah, I would recommend going to the docs and kind of getting started with tutorials. And of course, go to ZetaChain's Discord server if you have questions. I'm there pretty much 24/7. Well, not really, but I'm trying to answer all the questions developers have. So we have a community of developers, and you can get help there. But as you've seen, it's pretty easy to get started, right? It doesn't take more than like half an hour to go through a tutorial and actually make this transaction and see it yourself. And I think that's the key, right? Having all the tooling available for you to just kind of smoothly, kind of in a smooth way, go from zero to being able to what essentially is a decentralized cross-chain swap, right, in your contract, and then you can go from there, right? We also have, if you want something more kind of visual, more front end, we also have a front end example that has portfolio tracking, cross-chain swap, staking, and an NFT example is coming soon. It's going to be more engaging because it's like visual, right? It's not just the CLI. You're actually gonna see the NFTs that you're minting, and you'll be able to mint them, burn them, transfer them, and all this cross-chain goodness packed into a very simple, straightforward tutorial. It doesn't take more than 30 minutes to get started, and once you see how simple it is, I think you'll be ready to kind of watch more videos on YouTube on our channel, or read the rest of the documentation to understand more how it works.
Perfect. Yeah, that's a pretty good introduction to kind of where
Sorry,
developers
you're
can
muted.
start. Oh, am I? There we go. Appreciate it. I always end up muting on Discord, and I always forget that I'm muted. But yeah, I was saying that that's a perfect introduction. I think that's a great place for developers to start. What I really want to see is I want to see somebody build up like an application, maybe like a demo, and I've thought about this too, that leverages Particle as like basically abstracts away a lot of the Web3 experience, uses Particle for onboarding, and leverages ZetaChain as like almost chain abstraction in some sense. With a really deep integration, even further than just like an initial like decentralized cross-chain swap. I think that would be really cool to see. There's a lot of really cool opportunity here building with ZetaChain. I mean, really just from that example, like the opportunities here for developers in terms of what they can create, things that don't really exist today, that there's a lot of really cool potential for. It's massive. So I'm really excited to see what people end up building with ZetaChain, especially as you guys like continue to roll everything out, and continue to kind of increase developer adoption. I think it's, I tell this to everybody all the time, but like in terms of things that you can build in Web3, like we are in a golden age right now where like we're just getting to the point where it's like the tooling is there, right? I mean, you have like just this incredible suite of infrastructure. It's just up to developers to go ahead and capture that, and create something that's really valuable. So the big thing is that, of course, developers like you mentioned on kind of your documentation walkthrough there, developers that are already building on Particle that want to build on ZetaChain to, of course, introduce that sort of cross-chain interoperability within your own application. We do have our own ZetaChain tutorial, even a video that we produce, as well as a very long written tutorial. It's live in our new documentation, which isn't completely released just yet, but I think we actually have a link to it, maybe somewhere in our announcements channel. If not, you can go to the ZetaChain documentation, and then go to the Particle Network page and click on that link right there. That'll take you to the full tutorial, and you can kind of understand the process of building with ZetaChain in tandem with Particle. And then, of course, you can go further into their documentation, understanding the specifics of implementing that on kind of a deeper level. So Like I mentioned, if anybody here ends up building something with ZetaChain and Particle, DM me. I'd love to see it. I'd love to share with everybody. I think it is like the perfect intersection of two really powerful technologies. And Dennis, thank you so much for hopping on today and giving us a great workshop on the kind of the introduction to basics of working with ZetaChain. I think it was fantastic. I think for the chat here, I know that we wanted to kind of give 1 or 2 minutes just to answer some questions. The first one was the GitHub link in the docs. I think our bot is going to block your message. So if you want to DM that to me, Dennis, I will throw it into the chat there so that everybody can see that as reference. The other thing is, can you talk a bit about what you're building with Merlin Chain? Yeah, so this is on the same idea, kind of what we were talking about a moment ago. This isn't directly related to ZetaChain, but like I mentioned, Bitcoin is kind of a big thing that's coming into the ecosystem now, especially when it comes to, promoting cross-chain interoperability through, Bitcoin layer 2s and Bitcoin layer 1. It's a big topic. So we are building with Merlin Chain right now on the Merlin testnet with our BTC Connect product which is directly compatible with ZetaChain if you want, to facilitate basically unified utilization of both Bitcoin layer 2s and Bitcoin layer 1s through a native Bitcoin wallet like Unisat, Xverse, OKX, etc. So you can imagine, even just in the Bitcoin space, having a user log in with their Unisat wallet, they have a native Bitcoin wallet created, they have a smart account on a Bitcoin layer 2 created, and again, same idea here, you can abstract all of the potential difficulties with moving assets across chains exclusively by using ZetaChain in a lot of cases. So I think even with the BTC Connect product that we just announced today, it is the perfect case for leveraging ZetaChain. So really excited. Everybody that is in here, appreciate you hopping in. What I'm going to do is take a quick screenshot of the chat here. That way I can reference this, or not the chat, the audience list, so I can reference this later for those that are in here that are verified developers, and I'll add that to my list. Other than that, Dennis, anything else from your end before we kind of close out the workshop here? Any closing thoughts from you?
No, not really. I think it's a great time to start building, and Omnichain dApps is the most scalable architecture that we know of. So yeah, I invite everyone to check out ZetaChain docs. And again, thanks for having me. It was a blast, and I hope it was useful and interesting for people. But yeah, see you all on Discord. If you have any questions, happy to help.
Perfect. Well, Dennis, again, thank you so much for hopping in today. Everybody in the chat, go check out these ZetaChain docs and the ZetaChain GitHub. Also, like I mentioned, this entire thing is recorded. So you can head over to the YouTube link that I pasted in the chat within the workshop channel right here to go view this recording after it is ended. Other than that, I think that is about it. Dennis, thank you. And we will be back in, I guess, 5 or 6 hours for the Taiko workshop. So if you guys found this interesting, definitely stick around for that. And we will be back soon for that. And I appreciate everybody hopping in. We will go ahead and close it out now.
Bye.
Thanks, guys.